All right, so this is part 2 of what we started the video. Today we're talking about solving for linear inequalities or graphing for linear inequalities. Just like we did equations where we solved for x before, and then we did a quiz where you solved an inequality for x. Now we're solving it when there's an x and a y, and that's going to give us a graph. So this is part 2. Stick with me again, pay attention, and get some more penny action in there, maybe some more surprises and guest stars. Okay, so part 2. Gotta give the people what they want. So we're talking about solving for inequalities now. So I'm gonna use the same example that we did before. Before I said y is equal to 2x plus 1, but an inequality is no longer equal to. An inequality means that your answer is less than, greater than, less than or equal to, or greater than or equal to, or your answer could even just be not equal to. Okay, so rather than writing this, which is old school, now we're going to do y is less than 2x plus 1, because an inequality, I'll write it, an inequality means not equal to. There's no equal sign in an inequality. That's the difference here. So we're not doing this one anymore. We are doing this one. Okay, so it actually, why I said we spent so much time on this, we worked so hard on this, is because I set a foundation for you. So now it should be a lot easier just to get started because it's almost the exact same thing. Maybe, actually, I want you to see if you can logically figure this out. So I'll give another Dora the Explorer weight to show you. So I'm going to do the same thing I did before. I'm going to make myself a little table. And I'm going to make myself a graph because what I'm asking you here, what they're going to ask you on an end of course test is they're going to ask you to graph an inequality. I promise you they will. I love doing that. Okay, so I just want to figure out coordinates. I want to figure out coordinates for this. And it'd be great if you did the y-intercept and the x-intercept. It's good practice. So actually I want you to do the y-intercept and the x-intercept. However, you can find any coordinates. It's still going to be in a line. So that's neat. Look at that. When x is equal to 0, what is y equal to? And actually, I'm going to take, not a whole bunch of time because look, it should be the exact same thing as it was before and on the last equation, but I'll go back through again. So when x is equal to 0, y is less than 2, substitute in a 0 plus 1. Y is less than 0 plus 1. Y is less than 1. Whenever x is 0, y is anything that is less than 1. Okay, let's try another one. Y is less than, let's do when x is, doing the same ones I did earlier. 1, when 2, 1 plus 1. When x is equal to 1, y is less than 2 plus 1. Y is less than 3. We didn't do this last time. Let's do the x-intercept. At the x-intercept, y is equal to 0, so we could even do it that way. 0 is equal to 2x plus 1. That's, okay, I'm sorry, I'm not doing equal to. You should have said that. Good for you! Minus 1, negative 1 is equal to, why do I keep doing that? Negative 1 is less than 2x. Those cancel. So whenever y is equal to 0, those cancel. Let's see if you can read this. Remember, the alligator always eats the bigger one. Whenever y is equal to 0, x is bigger than negative 1/2. Whenever y is equal to 0, x is bigger than negative 1/2. Actually, that says less than 1/2, so I'm going to say, oops, it is greater than, because 1/2 is smaller. See, this is why I don't love the alligator, because it can be a little confusing with this. But I'm just writing it because alligator eats the bigger one, so it must be bigger than. If you hate writing the signs, you can even write just bigger than, smaller than, and this was supposed to be smaller. So, graphing it. Here is the piece de résistance. This is the This is the main idea of what we're doing. So we have some different coordinate points. We're still going to put dots for those points. This is new, so bear with me here. Whenever x is 0, we know y is 1. Put a dot. We know that when x is 1, y is 1, 2, 3. It should look just like our last graph. We know when y is 0, I didn't do this point last time, x is negative 1/2. And just so I'm not confusing you, I can do a better point than that. Here's a 1, and it's negative 1/2. So let's do 1, 3. I'm just going to write the coordinates. You don't have to do that, but it's just good so you can see it so you're not confused. These are my answers. Negative 1/2, comma 0. Now, how do I graph it if it's an inequality? So I didn't ask you what they're equal to. Every one of these says when x is 1, y is equal to 3. This one says when x is 0, y is equal to 1. I don't want to know equal to. This is a problem. I was asking, what is it less than or greater than in some cases? Any thoughts or ideas on how I could represent that with a graph? Think of an idea real quick. Say it to yourself. Also make a fart noise at your computer. That's an order. It's going to be hilarious. Okay, now get back to work. So, what can I do here? I'm quietly waiting for you to think of your own answer. Just get all the answers from me. How do I represent less than for this? Let's see. If I were to put a straight line, like this, this tells me that everything is equal to. So I can't put a straight line because it's not equal to. It's an inequality. I got to put a dotted line. A dotted line shows that, while this is the limit, it can't actually be any of the points on this line. You should use a ruler for this. Not as a helicopter, but you should use a ruler just to put it down there because that's a terrible dotted line. So it says that it is not equal to these points. If the equation can be equal to those points, then your line should be solid. If the equation can't be equal because less than is not equal to, it's not equal to, then you should have a dotted line. Again, just a quick review, dotted line means that it is not equal to those points. Straight line means it is equal to those points. And we know our equation says that it is not equal to those points. That's point 1 that's new, is that right there. Point 2 that's new. Well, I have a lot more answers. This actually didn't give me any answers. A dotted line says that it's not equal to. I didn't ask you just to tell me everything that's not equal to. If I wrote this, tell me when y is not equal to 2x plus 1. Oh, well then you're done. You showed me what it's not equal to at these points. Actually, this could be more. That's something you'll never see, but maybe I'll just give you that later. See if you understand. So let's go to this one. Let's go to when x when x is 1 and y is not 3. Okay, when x is 1, it says that y should be, when x is 1, y should be everything that is smaller than 3. So how can I represent everything that is less than 3? Well, you know what you can do? There's a shorter way later, but let's just start with this. I have something for this. Get an update of my crib. So, I can say whenever x is 1, y should be everything that's smaller than 3, and I should say, okay. And draw a line going down from 3, because whenever x is 1, y is not equal to 3, it's equal to everything that is less than 3. Okay, what if I said when x is 0? When x is 0, y is less than 1, so I draw a line. It says everything less than 1. And look how my lines kind of, it's my own fault for being messy, but look how my lines kind of met up. It actually works out, because I'll show you in a second. When x is negative 1/2, y is everything that is, when y is 0, x is everything that is less than 1/2. So, should draw everything that is less than a half right here. And I can keep plugging in any of these points. I realized that I should stop and go through that because I realized that seems a little confusing with the negative 1/2. So we solved. We got 0 is less than, just a matter of, so I don't love the alligator, 2x plus 1 minus 1 minus 1, negative 1 is less than 2x divided by 2 to cancel out 2. X is, so actually it's saying that x, whenever y is 0, x is everything that's greater than negative 1/2. And we're talking about x, so it'd be everything that is on x is greater than 1/2 would be going that way. It's a really good point though. Sorry if I lost you on that, just remember y is up and down. We said that x is everything greater than, so x is left or right. Confusing, I know, don't stress about that. But here's the thing, if I kept solving, maybe you need me to solve another one. Let's do y whenever x is equal to 2. Real quick, y is less than 2, 2 plus 1, y is less than 4 plus 1, y is less than 5. Whenever x is equal to 2, y is not equal to 5, y is less than 5 right up here, so it's also going to be here. So no matter what, if I choose decimals or I choose any x, or I even choose different y's, guess what? Look where it's shaded in. Every answer is going to be shaded in over here. So I can actually make an assumption and say no matter what I plug in for y, this entire area is going to be shaded in. Why am I shading in the areas in between? Because look, if I did a fraction, it would still go down from right there. If I did a fraction, it would still go down to right there. And this is the fun part, is you can choose any color you want, and you can just shade in. And that is it. So things to check back and remember on. My line is dotted. Why is my line dotted? Because y cannot be equal to those points when x is equal to that. Y is less than those points. Dotted shows that it's not equal to. Straight line shows that it could be equal to those points. Also, I shaded the area below, and people think, oh, you just shaded below. It says less than, you just shaded below. Well, yeah, but why did I shade below? It's important to know why. It's because whenever x is equal to this, y has to be less than that. And we drew a line under, but ultimately we're going to keep, waiting for you, drawing lines under over and over and over again. Okie dokie. I know you wanted a penny video, but we'll just have to hold on for the next video. Stick with me.